All right, so first thing I want you to do, go back to Pear Deck. Okay. Going back here. Okay. I'm going to put a picture up there. I just want you to tell me, what do you think that function is? Whoop, that's not what I want to do. That function there. What is that function? Type it in. Everybody give me a response. What is the function? Okay. All right, I'm seeing y equals x. It's something linear. Y equals x. It's linear. It's definitely a line. We're looking like the function y equals x. Okay. I'm going to show you the function on my calculator. Okay, so here's the function on my calculator. And I'm going to show you, I'm going to look, let's look at my window. So look at the scale on my window. So it's saying that my window is showing you from negative 0.6 to 0.5, okay? And from negative 0.4 to 0.4. Notice this is 0.05 right there, right? So it's kind of zoomed in, isn't it? Right? This is 0.5 here, and that's 0.4 there. That's pretty zoomed in. Let me give you a slightly different picture. Let me change my window a little bit. All right, I'm gonna make sure I gotta get my right window here. All right, so I'm gonna change my window. I'm gonna change it from like -3 to 3. Okay. Ooh, that's not what I wanted to do. It was less impressive than what I wanted to have happen. All right, and then I'm gonna go negative. Well, I'm gonna go -1 to 1 or -2 to 2. I don't know why they have it scaled this way, but oh, you can totally see my function now. What's it a picture of? What makes a wave like that? That's the sine curve, right? So I had it way zoomed in. It looks like a line, right? I zoomed that way in, it looks like a line, but it's really was the sine curve. So that kind of begs the question of, I can get that to look like a line. I wonder if I could use something other than sine to estimate sine. Okay? Because it would be really nice if I could have something that I would estimate sine. Who's this from? Okay. All right. So let's see if we can create that. Okay, so here's what I want you to type into your graphing calculator. So everybody's going to type in sine x into F1. Remember, you want to come over here and use the trig button to do that. Okay? If you don't have your calculator, go ahead and grab one over here. Okay? So everybody's typing in sine x there. Okay. And we just said, hey, we can probably estimate that with y equals x, right? It was an actual estimate for it. So when I zoomed in at F, so I'm going to go to F2 and I'm just going to type in x. So we should have it look like that. So sine x and then just x. Because I know, and I'm just going to, you don't have to do this part, just watch with me, okay? Window zoom, window settings, not window settings, cancel. Menu, window zoom, zoom in. If I, ooh, that's not what I meant to do. If I zoom this in enough, right? Look at that, between like there and there. Ooh, that's not what I meant to do. Let me pull this here. there is a spot where those graphs are identical, right? We would all agree that there is a spot where y equals x and sine x are the same exact graph. And that little section right there, they're exactly the same. So I'm kind of curious. I'm going to go window. I'm going to zoom standard again. Okay. I'm curious what this difference is in between here, between that graph and this graph. What kind of a function does that look like? And maybe I could use that to help my estimation a little bit. See if I can close that gap a little bit. So I'm going to go in here and I'm going to try to figure that out. So I'm going to go var f1 of x minus var f2 of x. I'm just subtracting the two functions. And I want to see what that new function looks like. What kind does it maybe look like something that I know? So my sine function minus that line, if I take that line away, what does it look like? Okay. And I'm not zoomed in enough. I need to zoom in some more. Let me zoom in a little bit. Okay. If I were just to look at that zoom version of it there, okay. What function does this kind of look like? Okay, it's something negative. Got it. Okay. So think about our polynomials that we know. We've got x squared, we've got x cubed, we've got x to the fourth, we've got x to the fifth. What does it kind of look like? It looks like a cubic function, right? But it looks like a negative cubic function. All right, let's see if we can get just a good estimate on what that function, that piece is right there. Okay. All right. So, and I'm not worried about, let's see if you guys can change your windows for me. Let's go in here to this window and see where my window was and just get it on this window. So let's try our window from -3 to 3, -3 to 3 on the x. Okay. And maybe just -2 to 2 on the y would be enough. I'm getting close. I zoomed in on what I had it there, but let's try that. So let's try to keep it in that window. Okay. It might move itself. The inspires are really good at moving themselves, but let's try to keep in that window. And so we don't confuse ourselves for now. We're going to do a lot of turning on and turning off of our graph. So let's go up and turn off both the red and the black, or the red and the blue graph, and just keep the black one on. We're going to see if we can get this graph exactly on. Okay, so we're going to see if we can figure out for that section of that graph exactly what is the equation. And you just told me it looks like a negative x cubed. So that's what I'm going to try. So I'm going to put that into F4. Negative x to the fourth. Oops, not to the fourth, to the third. Hit enter. I definitely have it going the right direction, right? What's wrong? Not the scale. What else can we do to a graph? We can make it skinny. We can also make it what? We can make it stretch, right? We can do that vertical stretch and compression. And remember, we do that by adding coefficients. Okay. If I may, let's just see what happens. Okay. Because it's been a while since we've worked with this stuff. Let's just put a 2 in front and see what happens. Did it get better? Or did it get worse? Got worse, right? It made it skinnier. So I want something that's going to make it wider, right? All right, so I'm going to go back in. I'm going to take the 2 off for sure. I know that that's not working. What happens if I divide by 2? Let's try that. Divide by 2. Did that make it better? It got closer to what we want, right? Okay, let's see if we can do better. What number should we try next? What do we think? Give me a number, any number. 5. Okay, let's try 5. Is 5 better? Is it the best? Let's keep going. Let's see if we can try something else. 6? Let's see what 6 does. That's pretty good, right? Like between here and here, they're pretty right on. Let's see what happens if I do 7. See if 7 makes it any better. I'm not sure if I'm in love with 6 yet. Let's see. The problem with 7 is it kind of went over, didn't it? See how it made it go over just a touch? Let me put 6 back up there. 6 I know is for sure right on with like going over. So let's go with 6. Okay, so here's what we're going to do. Okay. I'm going to go back to my graph here. Okay. And I know that my F2, I'm trying to create a polynomial that I can use to estimate sine. I know for a little tiny section of it, X works. I'm now going to put in minus, I'm going to put in that what we just found, what we subtracted there. X cubed, X to the third divided by 6. I'm going to hit enter. Right now I can't see anything, right? Actually, well, I can see that part now. Okay. So get that in there, and then we're gonna turn some stuff back on. So all you had to do was add on x minus x cubed over 6. Okay. So let's take a look at, so let's go back to, I'm going to turn off my black graph. No, I'm not. Yeah, I'm going to turn off my black graph. I'm going to turn off my pink graph. Okay, and I'm going to go turn my first 2 back on and see what happened. So my red one, my blue one, and my red one. Hey, look at that. So I now have, look at how much better I did, right? Now it's starting to curve just like sine is, but it's a polynomial versus sine. Okay. Think we could do better? Let's see. So actually, I'm going to write this down too before we get too far, because I want to make sure that we know our estimate here. So I'm going to go to, I just want to blank. Normally, this is the part that I go over and do on the board, and we kind of keep referring back to it. But because, so what we have done so far, okay, is we've said, hey, we think sine x is x minus x cubed over 6. Okay. Because so far I have, I've been able to add that on. Okay. I'm going to see if I can do better than that, though. All right. And see if I can make a better estimate and make a better polynomial out of this. Okay. So let's try to do that process again. Okay. So I'm going to go back. I'm going to turn off the red and I'm going to turn off the blue. Okay. I'm going to try that process and see if I could subtract the 2 things again and see what function I get and see if I can make a better estimate. So I'm going to turn the black one back on and see what it looks like now. Okay. It's still kind of looking cubic, but we already used cubic. What do you think should come next? Is it an odd function or an even function? When they're even, do they point the same way or opposite ways? Same. So this one is this one even or odd? This is odd. Okay, I've already used x cubed. What would be our next odd function? Okay, so let's try x to the 5th. So let's try tab. Okay, I'm going to go back to where I had this one right here, the pink one. I'm going to turn the pink one back on. And let's make it x to the 5th. Let's just do x to the 5th. Should it be positive or negative? It's tipping in the positive direction, right? So we're going to go x to the 5th. Let's just see if what that does to it and hit enter. Okay. The next thing I am going to do, okay, is I'm going to try to widen that again, right? So we did that by dividing, right? We did it by dividing a number. So we're going to try to get it to match up. Okay, so I'm going to divide by, I don't know, what number do you think we should divide by to start? 6? Okay, start with 6. Not better, but is it good yet? No. Okay, so here's what I want you to do. I want you to experiment and see if you can find the perfect number to divide by to get it as close as we possibly can to the black graph without going over like we did before. Okay, so I'm going to give you a couple minutes to try it. Okay, so keep trying it, see how close you can get, and we'll see if you guys can come up with the right number. Okay, everybody's on your calculator and everybody's trying to. Let's get the calculator out and do this. Okay. I'll give you about 30 more seconds. See if you can get that number. Tell me what you're going to be able to tell me what I should be able to play with here. All right, what number did we put on the bottom? 136. Okay, I'm waiting for a little bit over. Anybody have anything else? One what? 140. Still feel like, see how right here, if I zoomed really in on that, it looks like we're over the top of it, like we went over, and I want to be under a little bit. So if we go a little lower. How about like 115? Ooh, not 1015, 115. See how it brought it back where it's still kind of, it touches, but it doesn't go over the top of it. But let's see if I can get a little bit better. I have a number in mind, so let's try this one. 120. Right? It looks pretty good up to this point, right? And then let's see, what happens if I do like 130? 130, set it over. Yeah, 130, all of a sudden it definitely like crossed it. So I'd like to stick with 120. Everybody good with that? We have it, but we haven't gone over yet. We haven't like crossed that line over. It looks pretty exact for a good portion of it. Okay, so here's what we have really done. Okay, so and I went back and looked at my notes while you guys are working on that. I set it up a little bit backwards. Okay, so I didn't quite write everything down. So what we did in our calculator to start with was y1 or f1, not y1, f1 minus f2, right? The first thing we did was we got it to estimate to this negative x cubed over 6, okay? If I went and I isolated my sign, That means if I move that x over, my estimate for sine is x minus x cubed over 6. Okay? What we did now is we switched f1 and f2 to sine minus what we estimated for sine. And then we just figured out that that is approximately x to the 5th over 120. If I isolated sine net again, how would I take this guy and move him to that whole thing and move it to the other side? Add it, right? So that means that my estimate for sine, and I notice I'm using approximately symbols because it isn't exactly sine, it's an estimate for sine, is x minus x cubed over 6 plus x to the 5th over 120. Okay? I think let's see how good we've done at this point. So let's actually put that in as our next term in our calculator and see how closely we've estimated sine. Okay? So I'm going to go tab. Again, we're going to turn things off and on again. I'm going to turn that one off. I'm going to turn blue one off. I'm going to put plus, what is it? X to the 5th over 120, right? So control divide, x to the 5th. Oh, yes, I know there's a syntax there. I haven't finished typing it. 120. Turn the red one on, turn the blue one on, and see how well we've done. Okay, I'm going to hit enter. I know I still hear you typing a little bit. Oh, turn that on. Okay, and then I'm going to hit tab. I'm going to go back to my sine. Turn that one on. Is it better? Think we can do better? I know we've only got let's see, about 10 minutes left, right? Yeah. Okay, so let's see if we can get at least one more better. Okay. All right, so let's turn the blue one off, turn the red one off, and go back to the black one. Okay. Ooh. That's what the black one looks like. I could probably zoom out just a touch. Let me zoom out just a touch. Menu, window zoom. I'm just going to do one zoom out and we click once. Okay. All right, I can't repeat any of the polynomials I've already done because I already know what x cubed looks like. I know what x to the 5th looks like. What do you think that one is? 7. Okay, so let's try x to the 7th. Should it be, so I'm going back to the pink one. Turn it back on. X to the 7th. And I know it's not 120, right? I'm going to take the 120 off. Should it be positive or negative? Negative, right? It's tilted in the negative direction? Okay. It's nice and flat like the x to the 7th is, but I need to find a number to put on the bottom. Okay? So I'm going to give you no more than 2 minutes. Okay? So everybody try to find that number that is on the bottom. Okay? Don't just go up by 1 or 2, right? Make sure you're going up by hundreds or so every time. Okay. Everybody get close? What are we thinking? I put in 500. It wasn't good enough. What did we get it in there? Anybody get close to it? 5,000? Okay. That looks pretty good. I'm going to make one little adjustment. I want to make it 5,040. I want to make it really good. So I'm going to make it 5,040. Okay. All right. Let's see how good that was in our estimate. Okay. So I want to, let's see, let me go back here and we're going to record what we just did. We just figured out that sine x minus this mess here, x minus x cubed over 6 plus 5x to the 5th over 120 is possibly equal to negative x to the 7th over 5,040. Okay, so let's see if that worked, right? Because that was what we were hoping for. So I'm going to turn off the pink. I'm going to turn off the black. Okay. I'm going to go minus, I'm going to do a control divide. Control divide x to the 7th over 5,040. Ooh, I wanted to turn on the red one. Turn on the blue one, turn on the red one. Is it getting better? Looks like we're doing even better at estimating sine. So here's the thing. The nice thing about having a polynomial to estimate sine is that it's hard for us to just plug in sine of 2, right, and know what that is. But for a function like a polynomial, I could plug in f of 2 into something like this, and it would be really easy. Okay? So I'm going to write out my official sign now. If I was going to get this to the other side, how would I take that and move that whole thing to the other side? Add it. Okay, so we know that sine can be estimated with x minus x cubed over 6 plus x to the 5th over 120 minus x to the 7th over 5,040. Okay, I could probably keep getting better and better and better at this, right? What do you think the next x is going to be? 9. What's the one after that going to be? What's happening with the signs? Ooh, so that's got to be a minus. This one is going to have to be x to the 13th. There's got to be a pattern, right? So the question is, I don't want you to call it out if you think you know it, okay? Because this is going to be what I want you to walk in with to me tomorrow. Where is this number coming from in that pattern? Okay. The hint is I'm going to tell you it relates to the exponent. Okay. I want you to try to figure that out before tomorrow and see if, so really quick, scribble that down somewhere. Okay. Or take a picture of it. Okay. See if you can figure out what these numbers here should be so we can get a better estimate and figure out what another name for 6, 120, and 5, that's 120, and 540 is. Okay? If you think you know it, don't call it out yet. I want you to try to figure that out tonight. Okay? And come in with it tomorrow. All right? And then we're going to continue this pattern tomorrow and see how it relates to what we're doing for the rest of this unit. Okay?